attendance. I'm gonna get the grumpy email. Oh, sorry, it's being a jerk. There we go. All right, let me get our attendance marked, and then we'll get cruising. So get this part written down. I just want to benefit like an actual college course. There's no flipping attendance. So you know that you have to work 40 hours. 4, 5, 6, 4, so that's like, love it when everybody's here. It makes it so much easier when everybody's here. All right. So we're looking at completing the square, which literally means I want to turn this into something that is like a perfect square. Like I could factor it and we would get the same factor twice. So it's just like worded super weird, where it's talking about x plus k and x squared minus kx. And all we're looking at is if I was to say box this. Oh, that's chunky. And we were to make this like x squared, split this guy into 2 even pieces, so -4 and -4. What needs to be in this bottom box to make this a perfect square? 16. Because if I write this as x squared minus 8x plus 16, I could factor this and put it as x minus 4 times x minus 4, or x minus 4 squared. So what they're asking for is what needs to be added on the end here to make this stuff work. Sorry, these were -4x and -4x. What we do is we take whatever our middle term is. So here they're talking about k. Divide it in half because we split it into our 2 equal terms. And squared. So how we took that -8, we cut it into 2 pieces to put it into our 2 boxes, and then we squared it. So k over 2 squared is what we're looking at here. So you guys did it. It just looks super complicated written as a single expression. We took our -8x, we split it into 2 equal boxes. And so what they're wanting to know over here is what value needs to be added to make this a perfect square. It's just like we did over here. And if you like to do this as the box, you can. It's just going to get fractiony, and that's okay. Or we can use our little expression, where we take our what's in the middle. We divide it into 2 even boxes, 9/2. And then we square it. What is 9/2 squared? What's 9 squared? 9 squared is 81. 2 squared is 4. When you have exponents, you could also write it out. 9 over 2 times 9 over 2 and multiply across. Okay. So there's a whole section on the homework where you're looking at what number makes the square complete. So all you have to do is find me that value that would be added on the end. we could write this, if we were to factor this all out, we would get x plus 9 over 2 squared as our factor. It's always going to be whatever the inside piece here is. Right now, we're just focusing on the what gets added on the end, and it's k over 2 squared. K over 2 quantity squared. Yes, dear?
If we did the box, would we do the decimal?
You could do the decimal. 9 halves being 4.5. 4.5 squared is still 81 fourths. It does not have to be a fraction. I am fine with decimals. It's just harder. It's harder. It's a lot harder to simplify like that, but I'm cool with it. If you down for decimals, go for it. Yes, dear. So for this one, the answer is the 81 over 4. Hello. All right. Sweet. We got presents. So, Sadie, for you, and Belsie. Go ahead, Desmond. What's up? Belsie.
So if that is x plus, if that's not the answer, what's the answer for the first one? 16?
Yeah, the answer for the first one is 16. All it was asking is what number needs to be added. These guys are our answers. I just went a little farther to show us the connection, because otherwise we're stopping halfway through and it makes my brain twitch just a little bit. So then we're going to look at what would be the middle term. It's the same process, like the same concept. We're still trying to make it be a completed square. What would need to be in the middle for 36 to work as a perfect square? Careful. I see where the 6 came from, where you got that, because we would want this to be x squared, and we would want this to be 36. What's going in each of these boxes? 6x, which means how many total pieces do we have in the middle? We have a whole lot of options going on here, y'all. 12. 6x plus 6x? There it is. I heard that one. I love those ones so that. Oh, yeah. Remember, you pull all the pieces out of the box and add them up. If you like the box, rock the box. So the value of D for this one would be 12.
Oh. Could you show it the other way?
Yes. So
Cut that out a little bit.
the other way to think about it is that 36, let's see, skinny pen, there we go. 36 is our k over 2 squared. So square root of 36 would be plus or minus 6 equals k over 2. So we could have 12, or we could have negative 12. So you actually get an extra answer when you do it the calculatorily way. Because I could have x squared minus 12x plus 36. So you can do this either way. You get to the same kind of point. Okay?
So the answer is 12 or plus or minus 12?
Mm-hmm. Plus or minus 12 would be better if we notice that. But if you just get the 12, I'm okay with that. Okay? Because if we had minus 12, it would be x minus 6 squared. Or I could have x plus 6 squared. Just drawing a barrier. Say it louder. Those are two separate thoughts right there. Yeah. It's okay. It's weird. And the way they've worded this is weird. So I took the 36 and said, I know this 36 is this piece. So we solved for k. K gives me plus or minus 12. That's telling me what's going in here. Into the middle. That one doesn't have a value yet. We're solving for it. Okay? So let's do the last one up here for this part. The reason we're doing 4 of these is there's a problem very much like this on the homework, where you have to find this missing value. So there's a question that asks you 4 times to find the missing value, which is why we're doing it 4 times. Okay. So I'm going to do this one this way, because it's all fractiony and kind of gross. Doing it in the box is going to be annoying. So I know that my 49 over 4 is the piece that would be added for my perfect square. So that's my k over 2 squared. So if we square root both sides, square root of 49 is, square root of 4 is 2. So we're plus or minus 7 over 2 equals k over 2. What's k? Plus or minus 7. So doing it the calculatory way is like fast and efficient. Sometimes this is a little easier to see. I don't care how you do it. Go ahead, Jasmine.
Is it A equals or D equals, or does it matter?
We're talking about the same thing. K was the expression we used on the front pages, which is why I had K on there. But we are looking at D here. K is D is 7. Correct. Multiply both sides by 2. Yeah, 'cause what we did was we times by 2, and 2 cancels to get our K. Okay, so there is at least one question on the homework that asks you to find the missing value. The whole point of this is to be able to complete the square so that we can use square rooting both sides to solve something, because we're solving. Like these guys. So we're going to solve with completing the square. And when we're looking to solve by completing the square, we're going to kind of isolate this piece. So it's going to feel real awkward here for just a second, because it's like the opposite of what we normally do for factoring, where we make it equal 0. I don't care if it equals 0. I want all my x's by themselves. So I'm going to subtract 7 from both sides. I know, feels weird. So we're going to have x squared plus 6x. I'm going to leave myself a little bit of space here. Equals minus 7. And what we're going to do now is we're going to do just like we did on the previous page. What can I add here that's going to make that be a perfect square? What? Not, remember, k divided by 2, split it in 2.
Oh, 3.
Square it.
9.
9. So we're going to add 9 on the end. We are in an equation, so I cannot just willy-nilly add 9 to one side. Add it to the other side as well.
Bro, that's the thing.
So we're taking 6 divided by 2, squaring it, and that's where we got that 9. This is the k over 2 squared. Okay? I filled in this 6. That's where those pieces came from. The reason we want to do that is because x squared plus 6x plus 9, if we factor that, we get x plus 3. X plus 3. Or x plus 3 squared. Right? Equals negative 7 plus 9, 2. We okay on how I did that? Okay, because I know it still feels real awkward right now because you're like, why? I know. How do I unsquare it? Square root it. Square root both sides. That makes the square root and the square cancel out, and we're going to have x plus 3 equals plus or minus square root of 2. Get x by itself. Subtract 3 from both sides. X equals negative 3 plus or minus square root of 2. It's awkward, and it feels weird to do it sometimes, especially when it's fairly new. It feels weird. This jump to here is usually like a shortcut we'll take, and so it does make it go faster than having to quadratic formula down into something that has this. Because this is our answer. We couldn't factor at the beginning. Our roots aren't going to be rational. So we would have had to have quadratic formula it to get some really weird situations. I use math as a verb, so yes. I was like, because the math be mathin'.
Yeah.
And I be dying. What's up?
So we only gonna use this when it's equal to 0?
Nope. We can use it when it's not equal to 0. Because in fact, we made it not equal 0 first.
So why did we use this here?
These ones didn't have equal signs. This was the first step of it. We were working our way up to this. We just didn't solve these. This was just what value went into that space. Okay? This was our very first solving with it. So this is our solution down here at the bottom. It's this negative 3 plus or minus square root of 2. That's your answer. That is your solution. We are going to practice this a couple more times. Yes, Yes. Yes. It is a way of solving, just like quadratic formula is a way of solving. Okay. We're going to solve by completing the square again. This one is 2x squared plus 8x minus 5. I'm going to start by getting that 5 out of the way. I would like him to leave, please. Thank you. I want my x's by themselves, so we're going to add 5. We're going to have 2x squared plus 8x equals 5. Before we just start hopping in with trying to do k over 2 squared, I've got that 2 in front of the x squared. We don't like that when we're trying to get this to be a perfect square. So what we're going to do is we're going to factor out a 2 like a GCF. Divide this guy by 2, divide this guy by 2. So we're going to have 2x squared plus 4x equals 5. I promise there's a reason. Because could I get this 2 to leave this side altogether? How? Divide by 2. Because I would really like this left side to just be x squared plus 4x. Because then I can make it a perfect square. If I have 2x squared, I don't have any way to make that be x plus something squared. I can't do it. We need it to be perfectly squareable. English is a construct and grammar is a suggestion. That is one of many reasons I am not an English teacher.
Oh.
Grammar is a construct and spelling is a suggestion, and just saying. I've had at least one time when I've written a slide and I've spelled parabola 3 different ways on the same slide and it's never been right. Spelling is a construct. Okay. Yeah, no, spelling is not my forte. If y'all tell me I spell something wrong, I will assume you are correct. That's how bad I am at spelling. Like, It's entirely possible, and notice how I went to double check, and there's no words on my screen. You said it as a joke, and I went, really? Oh. That is how much I believe you. Okay? Just saying. Okay, so now I have this right side looking a mess, but the left side we're ready to play with. What number do we need to add here to make this be a perfect square?
8.
Middle term, 4. Middle term divided by 2. So 4 divided by 2 is 2. 2 squared. 4. Okay?
Oh, yeah.
Divide it by 2 first. Split it into 2 boxes. There were many, many people that said 4. There were also many people that didn't and then changed their mind. And that's okay. That's part of the process. We're not expecting perfection, especially not right off the bat. That's why we do some together. Okay, add 4 to both sides because I can't just change my equation because they don't like it. And x squared plus 4x plus 4 is also known as, factor it out, we get x plus 2 squared equals 5 halves plus 4. So that's 8 halves, 5 plus 13 halves. Doing in my head, so double checking, yes. Okay. So then we have, need more space. Okay. Square root both sides. So we get x plus 2 equals square root of 13 over 2. We're just gonna leave it like that because neither one of those is square rootable. I'm sticking with it. It's my new word today. We need to get x by itself. What do I do with it? Subtract it. X equals negative 2 plus or minus square root of 13 halves. I am 100% okay with that being your answer. If you're looking at answer keys, they will rationalize it where they multiply by the radical 2 in the bottom. So it'll be 13 times 2, so 20 square root of 26 over 2. Because they've rationalized it, multiplied by negative 2 over negative 2. So if you see it slightly different in an answer key, and it's because the radical looks weird, it's because they've rationalized the denominator. I don't care. My answer keys do not have rationalized denominators. Okay, so if you need to look at the keys, look in your book, that's fine, but they most of the time rationalize that denominator, getting the square root out. The 13 came from 4. If we make it common denominators, it's 8 halves plus 5 halves. 8 plus 5 give us 13 over 2. So we common denominated this at the same time that we added it. Okay. Whoop. Stop. No, I'm not doing that. Just freeze the jerk. Okay, so just watch out for that. If you're looking at answer keys, it may have a rationalized denominator. Feel free to if you feel like it, but I'm like, that's not the goal here. The goal here is to complete the square. We can combine with rationalizing if we have the time. We don't. Okay, we're gonna do one more of these. Like, no joke, one more of these. And then we might have time to work on homework in class. That would be amazing. Yes, dear.
Like, in future references, do you think we'll ever have time where if we're doing the problems like this one, where we can try it by ourselves and then we come back together and see if it's right?
Honestly, probably not.
Okay.
But I was like, I'm here Mondays after school. You can always like work on homework stuff and like text me stuff. My text line comes to my phone. You can always text me. You can come Wednesdays in 5th period. We can do stuff like that. But it's one of those. I'm not gonna promise that because there's just not always a bunch of time. Because so judgy. Goodness. All right. I want to do this one together still. 4x squared minus 12x minus 11. So first thing I'm going to do is I'm going to boot that 11 out. 4x squared minus 12x equals 11. And while 4 is a perfect square, I still would recommend doing it like a GCF. Divide out by that a value. So that we get 4 times x squared minus 3. X, there we go. I was like, that went weird. So that we have x squared minus 3x equals 11/4. I factored out a 4 as a GCF, and then I divided both sides by 4. Feel better? Because I heard a wait what? What number do we need to add here? So take the middle. 3 divided by 2, then square it. 9/4. Middle term divided by 2, squared. That is the trickiest part to remember. K over 2 squared. That gives us our factored form of x minus, watch out for this sign here for that, 3/2 squared. Okay, do we see those pieces?
No.
-3 as our middle term. We're putting that in our k over 2 squared. So that becomes 9/4. That is where the green 9/4 came from here. This will always, wrong color. This will always be that term. The b over 2, or the k over 2, middle term over 2, is going to be what the back half of our factor is. K over 2 is always going to be the x plus or x minus squared. So then we have 11/4 plus 9/4, which gives us 20/4. 20/4, does that simplify?
Yes.
To what? 5. I like that better. That's way easier to write. Okay, feel better now? Where all the pieces come from?
Yes.
Okay. Then we square root both sides. I need another color. Let's get blue. There we go. Square root both sides. And we get x minus 3/2 equals positive or negative square root of 5. Get x by itself. X equals, add 3/2 to both sides, so we get 3/2 plus or minus square root of 5. And that's not a highlighter. There we go. And that is our answer when we solve by completing the square. If you were to solve this with the quadratic formula, you would get the exact same answer. Exact same answer. But it's just kind of a different approach to it. Okay? Questions? You guys have homework time. What? Work on homework and ask questions. Ask questions. Yes. And I can maybe finish passing out homework. Yes. I love that.